Alright guys, welcome back. Starting from today, we're going to move on to Unit 8, Deductive Geometry. This is the last unit of the whole year, and we are going to focus on just one chapter, chapter 19. And you will see that later, the whole chapter is basically about circles. So let's get on to that. Now today we're going to start out with just two basic circle theorems. And before that, let's take a look at all the terminologies of a circle. Okay, as you know, we're going to start out with center. And if you stretch from the center to one edge of the circle, you're going to get this length called radius. If you start with one edge, passing through the center of the circle, all the way to the other edge, right across you, we call this length the diameter. Okay? If you just start out with one edge, randomly, without passing through the center, like this is the chord. Okay? We probably didn't really see the chord a lot, but we will start dealing with that a lot in this unit. Okay? The last one is, if you start up outside the circle, passing through the circle, with only one point of intersection, and you're still outside the circle, then we call this line the tangent line. Alright, so basically the whole idea is this. Okay, so these are three different levels. So the first one is imagining you're cutting a cake. Okay, so if you're right in the middle, okay, so you're right onto the middle, then the length that you're going to form is the diameter. Okay, if you're kind of missing a little bit, that you cut, you're still having 2 points of intersection on the edge, but you're not right in the middle, then we call this the chord. Okay, and if you unfortunately just slice the edge only once, right, you don't really get anything in this case, then in this case we call a tangent line. Okay, is there a worst case? Yes, of course, right, you can just be cutting over here. That means you don't make any point of intersection, and I don't think we have a name for this. So I hope this gives you a pretty brief idea about circles. So let's get on to the main concept today. Now here are the two basic circle theorems, and these are the main concepts for today. Let's start with the first one. The first one is called the angle in a semicircle. But let's look at the logic over here. The logic is, if you actually have a semicircle, that means if you have a semicircle, then that has to be a diameter, isn't it? So that basically means if you have a semicircle, if you have a diameter, then I can guarantee the angle B across the diameter, right across the diameter, being 90 degrees. So the logic goes this way, okay? If I know I have a diameter, then I can guarantee 90 degrees. Okay, but we also have a converse for that. Right, the converse is converse 1 below, right? So this is the other way around, actually. If you actually are only given 90 degrees, we are not given anything else. We don't know whether AB is a diameter or not, or maybe it could just be a chord, right? But this theorem guarantees that, you know what, if you have a 90 degree, we can also go the other way around. So 90 degree also guarantees that this line will be the diameter. Okay, so the logic goes the other way around. If you have a 90 degree, then I can also guarantee the existence of a diameter, which is actually right across my 90 degrees angle. Okay, so this theorem is very strong because it works both ways. As you see in one of my previous lessons, not all the theorems actually can go both ways. So that means this is a very strong theorem, and we definitely play a lot with this. Okay, so let's move on to the next one. The next one is called chords of a circle. So now if you have a chord, and we start out with a circle at the center, if you want to draw a line from the center, and this is not only just a random line, this line actually has to be perpendicular to the chord. Okay, so if we have all that, then that means you not only cut the chord perpendicularly, you also bisect that. Okay, so the logic goes like this. Okay, if we have a center, and then the center cuts the chord in the perpendicular way, so it not only has to cut, it has to cut perpendicularly, right? And if we cut you perpendicularly, then we will not only cut you perpendicularly, we will also bisect you, right? So this is what the logic feels like. Okay, we also have a converse for that, and you can kind of guess it already. It works exactly the other way around. So if you have just a chord, okay, we started with a chord, we have nothing else, we don't know whether anything will pass through the center or whatnot, and if it cuts me perpendicularly and bisects me, then the following thing will happen. Then this line that cuts you perpendicularly and bisectly will happen to pass through the center of the circle. Okay, so the logic goes like this, right? So if you have a line that bisects you, okay, it not only bisects you, but it bisects you perpendicularly, then you can be sure that this line that bisects me perpendicularly actually passes through the center of the line. So we can use that to locate the center in the future. This is also going to be very useful later. So that's it for these two theorems, and we're going to play with that for the next few examples. Example number 1, find x giving brief reasons. Okay, so we're going to show you how to give brief reasons now. Now first of all, let's start out with the fact that ABC is equal to 90 degrees. Okay, so here is where we put brief reasons. Pretty much the same as when we prove similarities and congruence. Okay, so here I will say it's 90 degrees because we actually see a semicircle over here. Okay, so this reason over here actually came from here, this thing over here. Of course, you don't have to actually write the whole name, right? For example, I just wrote semicircle, then people know that we're talking about this theorem over here. Now I know you definitely have a question. Do we need to memorize all the names? The short answer is no. Okay, at least I will provide you with a list of all the names. Okay, of course, I won't tell you too much information on the test, but I will try to give you, at least the names, and probably with associated diagrams. Probably won't tell you what that's about. Then I think that's pretty much fair, and that should be able to give you a lot of ideas on the test. Okay, so try to be short. Semicircle is fine, but make sure you actually give a reason on that. So let's continue with that. We will have x plus 10 plus 3x plus 90, and that equals 180. Okay, do our calculation. We got 4x plus 100 equals to 180. We got 4x equals to 80, and x is equal to 20. And that's it for this question. Second question, we have a circle with radius 4 and a core with length 6. Right, this question doesn't really give you any diagram, so we actually have to draw by ourselves. And the question asks us to find the shortest distance from the circle center to the core. Okay, so let's see what we have. Let's start out with drawing the radius. Okay, so the radius is 4. Let's put a 4 over here. And then we have another core that has length 6. Okay, let's say from here to here. And let's give it a name. We'll call it AB. How about that? Okay, so the full length of that is 6. And we want to find the shortest distance from the circle center all the way to here. We know that the shortest distance has to be the one that is perpendicular to the length, right? You definitely won't think this one is the shortest distance. By convention, we always name the center O, and let's call this point M over here. Okay, so first thing we will claim is OM bisects AB. Okay, this is because we have the core of a circle. Okay, this is the second circle theorem that we mentioned today. So that means what? That means your AM and BM should each be 3 and 3. Okay, and you realize that you can actually swing your radius here. So this is also 4 as well. Okay, so now you see a right triangle. You can definitely solve for OM. OM is, by Pythagoras theorem, this is equal to 4 squared minus 3 squared. Right, this is equal to 16 minus 9. The answer is root 7. So OM is equal to root 7 centimeters. Of course, you can write your answer in decimals, but this is fine as well. All right, last question of the day. This is a harder question on your textbook, page 415, question number 6. So let's do this together. So AB is the perpendicular bisector of the core CD. So we want to find the diameter of the circle. Now, the first thing that we know is we definitely know that the circle is on this line over here. This is because of the second theorem, the chord on a circle theorem over here, because if you see a perpendicular bisector over here, then that line is supposed to pass through the center of the circle. So that's what we know. Okay, but now we only know this part over here. This is 4, but we want to actually know the whole thing, which is the diameter in this case. So this is 4. Let's name this part over here X. How about that? Okay, so now the first thing I would like to find out is actually this length over here. This length, by Pythagoras, this is equal to square root of 4 squared plus 5 squared. This is equal to 16 squared plus 25. 16 plus 25, and that's equal to 41. Square root 41. And the next thing that I'm going to do is I'm going to find the length of this one over here. I can actually, because I don't know much information, but at least I can write that in terms of x. Okay, so this, by the Pythagoras theorem with this right angle triangle over here, we should be able to figure out that this one is x squared, square root x squared plus 25. Okay. Now the last thing that we need to use is actually the fact that this is 90 degrees. Okay, so we claim that ADB is equal to 90 degrees. This is because we have a semicircle. And now we know that it's 90 degrees. Then you get this triangle to look at. Okay, so this triangle with this part being known as 4 and this part remain unknown. And then this purple part is square root of x squared plus 25. And the green part is square root of 41. Okay, let's try and see if we can solve for x. Knowing that this is 90 degrees, we can use Pythagoras theorem. So we have, if we square everything, we're going to get x squared plus 25, right? So a squared plus b squared. Your b squared is square of square root 41, which is just 41. And that should give us the hypotenuse square, which is x plus 4 square. Alright, so we get x squared plus 25 plus 41 is 66, and that's giving us, guys, not x squared plus 16, okay, it's x squared plus 8x plus 16, okay? The cool thing is we can just cancel all the x squared, so we don't actually have to solve for quadratic. So we got 8x, throw the 16 to the other side, we got 50, ax equals to 50, x is actually equal to 6.25. Okay, but that's actually not our answer yet. Our answer is x plus 4, because we want to find the full length over here. So in this case, our diameter is just equal to 6.25 plus 4, which is 10.25 centimeters. And that's it for this question. It's a little bit more challenging question because it makes use of both theorems. And that's it for today. I'll see you guys in the next lesson. Peace.